Hey Cavaliers out there, it's Tracy Folks, ready to talk to you about gas laws after spring break. I hope everybody had a good break and we're ready to go and finish out the year strong. So, you notice that I have some pre-printed sheets for you to take your notes on, and we're just going to do some filling in of these notes. On the top of that sheet talks about gas pressure, okay? And you guys all know, you've heard people talk about tire pressure. You know, you want your tires to be filled with plenty of gas so your car can just put down the road. Well, what does it mean when you're saying gas pressure or tire pressure? And that's actually the number of times the gas hits the inside wall of that container. So when you're checking your tire pressure, you know, you're checking to see how many times the gases inside that container are beaten up on the inside of that tire. That's all it is. How many times did that hit? And in chemistry, we have several pressure units that we talk about, okay? The ones you're responsible for knowing for this year, the biggie is the atmosphere, and it's abbreviated ATM. And what does it feel like to have one atmosphere of pressure hitting you? It feels like about how it feels when you sit in my classroom. This is about one atmosphere of pressure. Now, it would be wonderful if life was easy and that was the only pressure unit we used, but that is not the case. We are also going to use something called kilopascals, okay? And one atmosphere equals 101.3 kilopascals. We might also use something called millimeters of mercury. Millimeters and Hg is the symbol for mercury. And we might also use something called torrs or torricellis. Now, these units can be used interchangeably, but you're going to have to be able to convert between them, and this is your conversion. And if you'll notice, a torr and a millimeter of mercury, they're exactly the same thing. So if I have 2 torrs, I have 2 millimeters of mercury, okay? The next part on your sheet has some conversions. So the first one says we're going to convert 0.3 atmospheres to kilopascals. Now, because I have brainwashed all of you, you are going to take what's given and put it over 1, okay? I don't want to be in atmospheres. I have to get rid of it. So that's going to go on the bottom. And I want kilopascals, so that's going to go on the top. Same setup we've been doing all year. The only difference is these are going to be 2 steps, and these are the numbers you have to remember to use. So everywhere I see kilopascals in a conversion, I'm going to use 101.3. Everywhere I see atmospheres in a conversion, I'm going to use 1. And you should be able to plug that into your calculator and get the answer, okay? Let's do one more and then we'll move on. All right, convert 1,050 millimeters of mercury to atmospheres. Take what's given, put it over 1. Convert millimeters of mercury to atmospheres. So I go back to my handy dandy cheat sheet over here. Atmospheres gets 1. Millimeters of mercury gets 760. Plug and chug. 1.4 atmospheres. So that's how we're going to do our pressure unit conversions. Now, the second column on your notes starts off talking about temperature. And you guys already know this from middle school, but I'm going to say it again anyway. If I heat up a gas, what do I expect those gas particles to do? Move faster. And if I cool down a gas and I drop the temperature, they're going to move slower. So I can say that temperature and I'm going to say kinetic energy, like how fast they're moving, are directly proportional. So as I increase the temperature, they're going to move faster. And as I decrease the temperature, they're going to move slower. Now, here's the other kick in the pants for temperature. Temperature must be in Kelvin, okay? And I'm really mean, and I am always going to give it to you in degrees Celsius. So you're going to have to remember that Kelvin equals the degrees Celsius temperature plus 273, because I'm never, ever, ever going to give that to you. I want you to know it. The next little blurb on your notes says STP. STP stands for standard temperature and pressure. Standard. And standard temperature is 273 Kelvin, and standard pressure is 1 atmosphere. Okay? So when I say a gas is at STP, that's the conditions that it's in. Okay? Now we are moving right along to our first gas law, which is Boyle's law. And Boyle said basically PV equals PV. P stands for pressure and V stands for volume. And just like in math class, because those variables are side by side, as one goes up, the other does the opposite. So if I told you that pressure was going up or increasing, volume would be going down, right? They are indirectly proportional. And there's an example there underneath that. It says a gas sample in a 10-liter container exerts a pressure of 565 millimeters of mercury. Calculate the pressure exerted by the gas if the volume changed to 15 liters. I see pressure. I see volume. All I do is plug numbers in and solve for X. So the first pressure in that problem is 565 millimeters of mercury. And the volume that goes with that is 10 liters. And the second pressure, I don't know what it is. It doesn't say what it is. So that's my X. And the second volume is 15 liters. You should all be able to solve for X. You should be able to multiply these two numbers and divide by that number. And when I do that, I get 377. Now that 377 needs some units. Oh goodness, shucky darn and slap the chickens. What kind of units am I supposed to use? Well, any units that are on both sides, I can cancel out. So that leaves me with that. There you go. Now we finished the whole front page. All right, now we're flippy poo-pooing to the back side of the page. And the back side of the page gives you another gas law. And that gas law is Charles's gas law. It is volume over temperature. Okay? V stands for volume, T stands for temperature. Remember that this temperature has to be in kelvins. So when you look at that example, and you can pause this and read it to yourself now. When you look at that example, the first temperature you see is 4 degrees Celsius. Well, degrees Celsius, I got to add 273, so I get 277, all right? What is the volume that goes with 4 degrees Celsius? Well, there is no volume, so that has to be my X. The second temperature is 22 degrees Celsius. So I add 273, I get 295. And the volume that goes with that is 0.5 liters. Now you should be able to solve for X because you should be able to cross multiply. So you should have 295X equals 277 times 0.5. And you multiply these two and you divide by this. Remember, whatever number is beside X is the number you divide by. Okay? And so you get 0.47. Because this was in liters, this is also going to be in liters. 2 more laws to go. Let me check my time and see how we're doing. Oh, we're good to go. The next law is Gay-Lusak's law. And Gay-Lusak said that pressure and temperature were directly proportional. And I don't think I said that with this one, but from math class, if you have variables on top of each other, if they look like fractions, they do the same thing. So if volume goes up, temperature goes up. If pressure goes up, temperature goes up. If pressure goes down, temperature goes down. Whenever you see them looking like fractions, they do the same thing. All right, so in the example for Gay-Lusak, you start with a pressure of 3.2 atmospheres and a temperature of 25 degrees Celsius. Because I'm a super chemist, I know that I have to add 273 to that temperature. So I end up with 298 K. The second pressure I don't know, that becomes my X. The second temperature is 500 degrees Celsius. I still have to add 273. There we go. So I'm going to cross multiply, okay? And I have 3.2 times 773 equals 298x. I will multiply those, divide by that, okay? When I do that, shazammy poo-poo, all right? Now the last gas law on your set of notes is the combined gas law. And basically what happens is all three of those gas laws we take and we put them all together and we end up with PV over T equals PV over T. When would you use this? If I gave you a problem that had pressure, volume, and temperature, you would have to use this one. So if you look at the example I gave you, the first pressure is 780 millimeters of mercury. The first volume is 350 milliliters, and the first temperature is 24.2 degrees Celsius. Got to add 273. There we go. And I'm going to erase this because this one gets a little bigger because you have the three different things going on. Now here's the kick in the pants, and here's why I wanted to do this one with you. And it said, what will the volume be? So I'm looking for the second volume at STP. Didn't give me any numbers. All right, but if you look on the front of your notes, we did STP. Where am I? Right here, okay? We said standard temperature is 273 Kelvin, so I can put that here. I know volume is X, and pressure is 1 atmosphere. Got an issue. Yes, pressure is 1 atmosphere at STP, but this pressure is in millimeters of mercury. So you're going to have to convert it, or you can cheat. If you look right up here, it says 1 atmosphere is 760 millimeters of mercury. So I have to put 760 millimeters of mercury here because this was in millimeters of mercury. Your units have to be the same. And to solve, we're just going to cross multiply. All I did was cross multiply. That times that times that equals that times that times that. You will multiply all of this and get a biggie number. You'll multiply these two and get kind of a biggie number. This number divided by this number, because this is by the X, to solve. So those are our exciting notes for our welcome back day from spring break. I hope you're in class and don't even need to use these, but in case you're not, here they are. Okay? You guys take care and I'll see you in class.